Thank you all for coming to this talk today. I'm glad to see so many people out here in the audience for this domain-driven design talk. So what are we going to be talking about today? We're going to be talking about domain-driven design, and what do I mean when I say a domain? A domain is a sphere of knowledge, influence, or activity. So that's just to be clear that we're all on the same page about what we mean by domain. This talk is based on the book Domain-Driven Design by Eric Evans. How many people here have read this book? Show of hands. A few people, awesome. I hope that by the end of this talk you are motivated to go read this book, because there's way more on this topic than I can cover in a 60-minute talk. So I hope this whets your appetite and gets you interested in learning more about domain-driven design. Also, there's a training provided by this company called Domain Language. This is a company started by Eric Evans, author of Domain-Driven Design. I had the privilege of taking a 4-day intensive class with them, and definitely worth it. So highly encourage you, if you really want to do a really deep dive into domain-driven design, check out Domain Language. More information is at domainlanguage.com. The key concept behind domain-driven design is that complexity is in the domain, not the technology. So as software developers, we tend to think about complexity in terms of our software, the complexity in the software itself. But we have so many frameworks today and high-level programming languages and so many tools at our disposal that the complexity really these days comes from the domain, from the actual domain that we're modeling. So don't add in additional complexity in the technology that doesn't need to be there. Focus on the actual complexity that exists within the domain that you're modeling. Speaking of modeling, in domain-driven design, we use models as tools to solve domain problems. So a model is just a high-level abstraction. It's just an abstract set of tools that we're using to solve and reason about domain problems. So don't think of a model just as code. Model isn't code. A model is a more high-level concept than just code. So a model is, like I said, an abstract set of tools. So when I say model in this talk, that's what I'm talking about. I'm not talking about specific code representations in code of the model. A key point with domain-driven design is to not try to model reality. That's not the goal here. We're trying to create and develop tools, abstract tools that we can use to solve domain problems. So I want to show you an interesting video here of an illusion called Ames Room. So if you can take a look at this video. So these two people appear to be quite a bit different in size. That's an interesting optical illusion that's happening here. And this is actually a quite simple illusion. This is just done through a room with a shaped, like you see here in this diagram. So the person actually is further away than they look. So this technique is actually used in Lord of the Rings, Fellowship of the Ring, to make the hobbits appear the correct size relative to Gandalf. So the point here behind this, why I bring this up, is this is an example of our brains using models to understand the world around us. So we're not actually perceiving an objective reality. We're using a mental model of what a room looks like, and we're perceiving that through that model. Even though it's completely illogical, it makes no sense, our brains still see it as one person being much larger than the other. So there is no objective reality. We're always using mental models, whether we realize it or not. We're always using models. Another example of models. I don't know if you can see that. Is that okay? So which model is better, Fahrenheit, Celsius, or Kelvin? So person who made this chart obviously thinks that Fahrenheit is a better model. But the point here is that it's about models as tools. What domain is Fahrenheit useful for solving problems within? One domain would be knowing what to wear today. So you know what, because you want to know what the weather's outside, like it is like outside. Celsius and Kelvin aren't quite as good at solving that particular domain problem. But if you're doing more scientific work, Celsius or Kelvin might be a better model. So again, the point here is that it depends on the context. Which model we're going to pick is a factor of what context we're trying to solve the problems within. To get a little philosophical here, this quote also gets at this concept that the map is not the territory. So what we're talking about here is a concept of, it's called map-territory relationship, where we're always interpreting the world through a map. We're always using maps, and there's this relationship between a map and a territory. And this concept is illustrated in this painting. It says, "This is not a pipe." Does anybody know what it is? It's not a pipe. It's a painting of a pipe. In fact, I could say it's an image of a painting of a pipe, or it's a projection of an image of a painting of a pipe. So this is illustrating that concept of map-territory relationship, that we're never actually looking at the territory. We're always dealing with these relationships between the map and the territory. Now this is just me having a little bit of fun. If anybody wants to scan that, you can, just a little joke I put in here. It says, this is not a QR code. So another point here, another interesting quote along these lines is this quote that everything simple is false, everything which is complex is unusable. So our job as software developers is to find something in the middle between these 2 points. We need to build something that's not so simple that it's completely wrong, but not something that's so complex and so like trying to match reality that it is completely unusable. So we're trying to, with our domain modeling, we're trying to find something in between these 2 extremes. Another key point with domain-driven design is that we want to collaboratively explore the model with domain experts and software practitioners. So as a software developer, you don't want to just go work in isolation and come up with a domain model. This is something you have to do with a domain expert. Now, if you don't have access to a domain expert, this is a problem you need to solve first. You need to figure out how you're going to get access to a domain expert, who you need to talk to make that happen. Because you can't practice domain-driven design without being able to collaboratively work with a domain expert. So an interesting historical example of this is the history of 3D animation. So this has actually happened long before domain-driven design, with the idea of domain-driven design came up. But I think it illustrates one of the key points behind domain-driven design. So there was this guy, Edwin Catmull. He was a software practitioner. He studied physics and computer science. He made a lot of interesting discoveries in computer graphics field, some really advanced stuff. Started out with 2D animation, then went into 3D animation. Ended up working at Lucasfilm, which of course later became Pixar, so that he could bring his expertise to the entertainment field. Now we take him, combine him with a domain expert, John Lasseter. He's an animator. His background's in animation. He was taught by veteran animators at Disney. And he realized the potential for computer-generated imagery. So he was pencil and paper animator, and he realized what computers could bring to the table. Worked at Disney, eventually got fired from Disney, ended up working at Disney again when they were Pixar. So Edwin Catmull, though, the technologist, recognized the importance of bringing on a domain expert. So he hired John Lasseter. And of course, he didn't have a role for him, so he made up a title, interface designer. Had nothing to do with what he was doing there, but gave him a job. So he recognized the importance of bringing on a domain expert. Also, kind of a piece of trivia, if anyone's ever seen the FreeBSD Beastie daemon, that was actually drawn by John Lasseter. But the key point, why I bring up this example, is this quote here. Throughout the process, Lasseter worked side by side with the computer scientist. Lasseter's request pushed them to develop new tools, and their feedback helped them learn the digital animation process. So this really gets at this idea of working collaboratively with domain experts and software practitioners, and developing new tools and really pushing the model forward by working side by side together. If we're going to apply these concepts, the first thing we need to do is we need to understand what our core domain is. So what's really important here? What's the reason why we're writing this software in the first place? So we want to identify that core domain, distill it, and focus our best resources on that core domain. How do we distill? So if we're looking at any given domain that we're dealing with, a domain is probably going to represent one of three things. It's either going to be our core domain, it's going to be a supporting domain, or it's going to be a generic subdomain. So core domain, that's the reason why we're building the software in the first place. That's why it's worth taking the risk of spending all this time on building the software. Supporting domain, that can still be critical, it can still be really important, but it's not the core. It's not the reason why we're building the software. And a generic subdomain, that could be something like an accounting package or accounting software, where it's this generic concept that, already exists. So like I said a moment ago, you want to focus your modeling efforts on the core domain. Some tactics you can take with supporting domains, you might want to consider outsourcing work on those. And for generic subdomains, you might want to use off-the-shelf software or pre-existing libraries for generic subdomains. How do you identify the core domain? So this one here, this here is useful. It's definitely useful to talk to domain experts, but here you also want to talk to organizational leaders, people that understand the strategy of why you're building the software in the first place. And you want to ask them some questions that will get at and help you understand what the core domain is. So some of those questions that could be helpful are, what keeps you awake at night? Why is the system worth writing? Why didn't we just buy it off the shelf? There's got to be some reason why we didn't just buy some pre-existing software. Why didn't we just outsource it? So the answers to those questions will help you understand where the contours of the core domain are, so you can really focus your efforts there. Another important concept is that we always have multiple models. So there's never just one model. So we're always going to have multiple models interacting with each other. So in order to make this possible and sane to work with, we introduced a concept called a bounded context. A bounded context allows us to tell within what context a particular model is applicable. So we can say we're working within this bounded context right now, means we're working with this model. Later we might be working in another bounded context, working with a different model. So it allows us to explore each of those models in isolation. And for each bounded context, we want to define who's responsible for it, which parts of the application is this bounded context applicable to, and what physical manifestations might this bounded context take within our application? What code represents this bounded context? What database schemas? So the actual kind of artifacts within our code. Within a bounded context, it's important to speak a ubiquitous language. So within a ubiquitous language, you want to clearly define unambiguous terms that you use consistently. So this is really important when you're working together with domain experts. So when you're having conversations with a domain expert, you can use this ubiquitous language to talk about further and further more abstract concepts. And these terms can have powerful meanings that you can use to express complex topics easily in conversation. This ubiquitous language will also end up in your code. So your names of your classes, for example, will follow this ubiquitous language. Your unit tests will use it. So this ubiquitous language will permeate throughout the entire software through everything, hence the term ubiquitous. And as you work with this ubiquitous language, as you use it and exercise it, it's going to get richer, and you'll be able to express more and more complex concepts with it. Now, at first, when you work with a ubiquitous language, you'll find it's kind of rough and has some rough edges and doesn't really quite express all the concepts it needs to express clearly. But over time, you'll work with that and refine that. I want to talk real briefly about a concept called strategic design. So I said we talked about bounded context a moment ago. So strategic design, we said we have multiple bounded contexts, we have multiple models. So if you're working on an existing application, what you want to do is you want to identify what bounded contexts already exist. So you do this through what's called a context map. So what's important here is assuming you're working with pre-existing software, you want to map what actually exists. So there's an ideal of what you're trying to go for, of how you want these bounded contexts to interact and how you want them to look. But the idea here is to map what actually exists, not what you want to exist. And you also want to go ahead and identify relationships between these contexts. And there's actually some relationship patterns I'll take a look at here real quick that can help you understand the relationships between bounded contexts. So partnership. This is where you have two teams working on two different bounded contexts, and they have a give and take relationship. So they work well together. They have a great relationship. They're able to send requests back and forth. They work together well. Customer-supplier. This is more of a one-way relationship where one party can request things of another party. Anti-corruption layer. This might be where you have a really messy bounded context with which you need to integrate, and you don't want it to mess up your bounded context. You want to keep your model nice and clean, so you can create an anti-corruption layer so that your model doesn't get all messy. Shared kernel. This is where two bounded contexts can actually share a core piece together. Big ball of mud means just what it says. Who knows what's going on? There's all sorts of dependencies all over the place. Everything's interconnected. Who the heck knows? Big ball of mud could lead to the next one, separate ways, where you just decide, you know what, we're not going to integrate these bounded contexts anymore. We're just going to completely go our separate ways and not connect them anymore. Open host service, this is one that you're probably familiar with. This is pretty much any web services API would fall into the category of open host service, where you just put something out there. You say you're welcome to integrate with it if you'd like. Here's how it works. Conformist, this is kind of the opposite of anti-corruption layer. Conformist is where you say, I'm going to just model my bounded context the exact same way that they've modeled theirs. I'm just going to conform to it as directly as possible. Published language, this is where there might be an existing standard that you can go by, you can reference. For example, Atom syndication format or Atom publishing protocol could be an example of a published language that you can use. So let's talk about some actual building blocks. So some code we can actually use to apply these concepts. So all the concepts I've talked about so far can be applied in pretty much any programming paradigm. These examples, though, are geared towards object-oriented programming. So I hope you can see that these concepts could apply to anything, any program paradigm, but since likely we're all using object-oriented programming here, we're going to be talking about it from that perspective. So first concept is an entity. An entity is an object that's identified by a thread of continuity and identity. Entity has two responsibilities. So it's only responsible for two things. You don't want to give it other responsibilities. It's responsible for its identity and its life cycle. That's it. No other responsibilities. It can be composed of other entities and other value objects. So you can actually end up with an object graph of entities referencing other entities and other value objects. Speaking of value object is something that's not identified by its identity. Instead, it's defined by its encapsulated attributes. So for example, a date might be a value object. A date doesn't necessarily have an identity, but it more is defined by its attributes. Now, I said date might be a value object. The important point here is that with entities and value objects, it all depends on the context within which you're working. So within one context, a person might be an entity. Within another, it might be a value object. Telephone number. If I asked most of you if a telephone number was a value object or an entity, you'd probably say it's a value object. But if you're building a phone switching system, a telephone number might in fact be an entity, not a value object. Value objects should be treated as immutable. Now in PHP, it's actually quite difficult to make something immutable. There isn't a concept of immutability. So the point here is that we're going to treat it as immutable. They don't literally have to be immutable, just as long as all the developers understand that they need to be treated as immutable and don't change state on them. This makes it safe to pass these value objects around without worrying about one thing changing state on you as you pass these value objects around your system. Business logic. Business logic belongs in your value objects, not in your entities. So we said that entities are responsible for two things, identity and life cycle. So value objects are where the business logic lands. Aggregate. So I said before that an entity could have an object graph. It could have reference other entities and other value objects. So an aggregate is a group of related entities and value objects that we define as one group, one object graph. So with domain-driven design, we're trying to focus on solving domain problems. So we're really thinking in terms of abstract tools to work with. Now, at the end of the day, though, we're building software, and we likely need to persist our data to a database or a data store of some sort. So we can't completely ignore things like transactions and distribution and concurrency. So this is where defining aggregates, you might actually base your aggregate definitions on these concepts of what needs to be consistent. things like eventual consistency. Do two things need to be consistent together or not? If they need to be consistent, they probably belong in an aggregate together. If they don't, if it's okay for them there to be some inconsistencies, they might belong in separate aggregates. And within a bounded context, you're going to have multiple aggregates. So you're not just going to have one aggregate, you have multiple aggregates. Now with an aggregate, what you're going to do is you're going to pick out one entity, and you're going to say this entity is the aggregate root. And you're going to allow only external references to that aggregate root. You're not going to allow things to go in and dive into the aggregate itself and get at entities or value objects within the aggregate. You're going to make them go through the aggregate root. Persistence. When you're persisting an aggregate, you're going to persist the aggregate root most likely, and that's going to also persist the object graph along with it. Speaking of persistence, we're going to use repositories to do this. It's a repository pattern. That's where we delegate our persistence to. So a repository is a pattern where we can send objects to it and get objects out of it, and it acts as if it were an in-memory data store. Now it's actually going to some back-end data store and storing the data, but as a developer, when we're working with a repository, we don't know any difference between that and it just being stored in memory. There's no, that's the interface that the repository gives to us. Now what this gives us is a really interesting technique we can use. In your tests, you can actually use an in-memory strategy for your repositories. So instead of your tests actually going to a real database and storing their data in a real database, you can just have it go in memory. So you don't need to worry about persistence yet when your initial domain modeling. You can just have all your tests happening in memory. And so as you're changing things like database schemas and stuff like that, you don't have to worry about all that yet. You can just focus on your modeling efforts. A lot of you are probably using ORMs, object relational mappers. If you are, just a quick note, a repository is going to use your ORM, so it's going to be, you're going to have your database, then your ORM, and then your repository. That's the order of how you'll stack these things. So I mentioned before that value objects are where your business logic lives. That's not always true. Sometimes you have business logic that doesn't make sense. It doesn't belong in a particular value object. It doesn't have a real natural home. In that case, you can create a service. Services should also be immutable. Now they can be configurable, so you can instantiate a service with a particular configuration, but once it's instantiated, it should be immutable. You shouldn't be able to change its state. If you need a different service, if you need another instance of that service with a different configuration, you can go ahead and instantiate that instance as well. But any given instance of the service, once it's constructed, should not have its state changeable. Likewise, operations on services are stateless, so there are no side effects to operations on services. So what does this look like? So I want to take a look at some examples of what all this might look like. So we're going to go through an example of an application that I worked on. It's an election reporting application. And this was actually a really interesting application for me because I didn't actually do the software development work on this. Usually, that's what I do, I'm a software developer, but this particular project, somebody else was doing the development work. But what I did was I worked with the domain experts and software developer to document domain knowledge and try to go through this process of model exploration process. So that was really interesting for me because usually as a software developer, I would just want to go and start writing code, but it was a great opportunity to take a step back and really understand the domain first. So this model exploration Whirlpool is a graph that shows one way you can approach this model exploration process. This is available at domainlanguage.com/ddd/Whirlpool if you want to check it out. The basic concept is this iterative process of going to a domain expert, talking to them about a scenario, have them tell you a story, really flesh out that scenario, propose a model that solves that scenario, that actually solves that domain problem. Then actually code that model as a test. So we actually use tests here as a model exploration tool. And then what you do is you go back to the domain expert with those tests, you walk them through the test using the ubiquitous language, and you say, does this make sense? And you're going to do this over and over again and refine this model exploration process. So this is a cycle. give you a minute to take a look at that if you want. Again, this is also available at domainlanguage.com/ddd/whirlpool. I'm sorry? Yep, so the question was, does it matter what type of tests, or is there a specific type of test I'm talking about? So I intentionally didn't use the word unit testing. Technically, what I do is I use like PHP unit, although conceptually what we're doing here is not unit testing. We're actually doing, it's more like integration testing, but it's not really integration testing either. But the tools we're using or that I use at least, are PHP unit. So unit testing frameworks will work just fine for this. But just realize you're conceptually not doing unit tests. Unit tests are supposed to test just one thing in isolation. And here we're testing more of a scenario-based thing. So, but whatever testing framework you want, you could work here. Yes? The what stuff? The question is, am I using the story-based stuff that's in PHP? Oh, PHP unit. No, I'm not using a story. No, I don't use that. I'm just using straight up PHP unit tests with assertions. So, yep. So I want to walk you through the specific example. So this is the ubiquitous language for this particular application, or this particular model that we're exploring here. Now, there are some flaws in this language. There are some inconsistencies. This language could use some improvement, but I think it's okay to leave the flaws in here because it points out that this is an iterative process, and this is something that's never really truly completed. So as we look through this, you might see some things that aren't quite completely consistent or some areas for improvement. That's great. If you see that, that means you're getting the concept. So, one of the domains concepts we came up with working with domain experts is this idea of an election event. So in our domain, election event is a set of districts voting on a set of ballot items during the same general period of time. Election event could include a primary, general election, or a town meeting day. So I'm from Vermont. In Vermont, we have this thing called town meeting days, which are in March, where we do just local elections. And then we have the general elections in November, where we have both local and statewide elections. Ballot item. Either an election or referendum as presented on a ballot. Pretty straightforward. Election. Formal decision-making process by which a population chooses one or more candidates to hold office for a given district. Could be tabulated at a polling place, ward, municipality, or district level. Winner or winners of an election may be determined by plurality and/or winning threshold. So what you'll see here is I've actually, in this ubiquitous language, I've actually underlined the terms that are defined in our ubiquitous language. So candidate has a very specific meaning. So when I talk with a domain expert or talk with other software developers, and I say the word candidate, I mean something very specific. I'm not just talking generally. I mean candidate as it's defined within our ubiquitous language. Now, other terms that aren't underlined aren't things that we've identified as the ubiquitous language. So there could be concepts in here that are implicit. For example, winner or winners. Those aren't underlined. So maybe the concept of a winner is something that should be made explicit. It's an implicit concept here in our ubiquitous language, but perhaps we should actually promote it and make it something more explicitly defined as part of our ubiquitous language. District, a distinct territorial subdivision for holding separate elections or referendums, blah, blah, blah. I won't read all of it, bore you with all of it, but basically the idea is that district could be either a municipality or a ward, it could have sub-districts, et cetera. Municipality, specific type of district, city, town, village. Ward, basically, some municipalities are broken down into wards, so a ward is a type of a district. Candidate, pretty straightforward. Winning threshold, so this is the method of determining winner or winners of an election. And you can see here there's actually some domain knowledge here in this particular definition. We've got some examples of different types of elections and ballot items. So so we're going to just walk through one scenario that we created with the domain experts. This is just one specific scenario. There are a whole bunch of other scenarios, but we're just going to walk through one here to illustrate the concept. So this is the election for Burlington City Councilor. So Burlington is the city that I live in. This is election for City Councilor in Ward 3. So the Town Meeting Day 2011 election event, again, Ubiquitous Language there, is underway. Ward 3 in the Municipality of Burlington is holding an election for City Councilor. This election has 3 candidates. It is 8:30 p.m. and Ward 3 has indicated the following results. We have a list of candidates, result, number of votes for each candidate, percentage. This election has a winning threshold of 40%, so candidate Vince Brennan appears to be the winner. Okay, so simple enough scenario. So next thing we do, so we've got our ubiquitous language, we've got our scenario. Let's propose a model. So what's a model that we could use to solve those problems illustrated in that scenario? So again, this model is intentionally flawed. There's plenty of room for improvement in this model. This is a first pass at the model. Again, we're going to challenge this model. We want to work on improving it. But again, I thought it was important to show you an early iteration of the model, so you got the concept of how you can just start simple and then iterate from there. So the proposed model here, model that I'm proposing, is that we have so first of all, we're going to define our aggregate. Our aggregate is going to be an election. The aggregate root is going to be an election. It's going to implement the ballot item interface because we have different types of ballot items. We saw in the ubiquitous language that there's not just elections, but there are also referendums. So both elections and referendums are ballot items. So I decided to make that an interface. We have election event. It's an entity. An election can have one election event. Election can have one district. A district can have a parent district. And then we have specific types of districts, ward and municipality. Again, these are all entities. Winning threshold. Winning threshold is a value object because there's no reason we can't identify a winning threshold. It's something that is represented by its encapsulated attributes. So winning threshold, we're going to implement the winning policy interface here for winning threshold because we saw in our ubiquitous language that there actually are multiple ways of determining the winner of an election. So we don't want to we want to allow some room for extension there. Now, here's a concept, the main concept that I've actually introduced. This concept of a winning policy hasn't shown up anywhere yet. So I need to go back to the domain expert and say, does this concept make sense? Is winning policy something that we should integrate back into our ubiquitous language? So here's an example of where it's important to circle back with the domain expert. Candidate. Candidate is also an entity. An election can have multiple candidates. So since we're on this slide, I don't know if there's some other bad design that I'll point out here. Jumping ahead a little bit, but election can have multiple candidates, and a candidate can have one election. Now you can actually, I don't know if you can tell, but the way this UML diagram is written, the election references its candidates, and each candidate references its election. For simplicity, you want to try to avoid those bidirectional relationships if you can. So this is an area where I might actually be adding additional complexity that could cause problems later. So try to use unidirectional relationships. So don't do what I do there on the left. Also, if you have one-to-many relationships, try to store the reference on the many side of the relationship. So ideally, candidate would reference its election, but the election wouldn't reference its candidates. Again, those are just some design tips for you to simplify things. Those aren't always possible, but if you can, we'll simplify things. So let's look at some actual code. So here's our election entity. I've kind of stubbed this out. Not all the code's here, but most of it should be self-explanatory. We've got our election class. Election class implements ballot item. As a construct method that takes its identifier. So remember, entities are responsible for what? What two things are they responsible for? They're responsible for identity and life cycle. So we construct an entity, we're giving it an identity. We're saying, here's your identity. Life cycle, so things like what election event does it belong to? So we have a set election event method. We have a set district method because we need to know what district this election belongs to. Add candidate. We want to be able to add candidates to the election. We want to be able to get a list of candidates back out, so we've got a get candidates method. And you can imagine, I didn't show the implementation of these methods, but it should be pretty straightforward to imagine what they look like. Any questions so far? Okay. Candidate entity. So here's another entity, also responsible for its identity. So we pass it its identifier. We also pass it what election it belongs to in the constructor. That's really just for convenience. We can set the number of votes that that candidate has, and we can get the fraction of votes that that candidate has relative to all the other candidates in the election. So again, hopefully you're seeing some flaws in this design already. Again, these flaws are intentional. So here's an example of a value object. So here's our winning policy value object. Now this is just the interface. Winning policy, we implement that as an interface, or create that as an interface, with one method that determine winners methods. Because that's what winning policies does. Winning policies determine the winners. And winning threshold, this is our value object for winning threshold. Now, since this is a value object, when we construct it, we need to set up its state. We need to set up its state in the constructor. So we want to treat it as immutable. So once it's created, once it's instantiated, we don't want to modify its state. So the constructor, we pass in the minimum percentage and the election that the winning threshold belongs to. Now we don't change the state from then on. If we need a new winning threshold, if we decide, well, actually no, it was 40%, now it's 50%, that's okay. Doesn't mean you can't change it. What you do is you get rid of this one and you replace it with another one with a 50% minimum percentage. Determine winners method here. This basically just determines if which candidates have more than the minimum percentage and adds them to the winners array and then returns that array of winners. So that's how this particular winning policy implements the determine winners method. So next, we're going to actually, so you've seen this ubiquitous language, you've seen the scenario, you've seen the proposed model. What does this look like in tests, in our actual tests? So here, again, the point of these tests is to explore the domain model. So these are not, while they're written as unit tests, these are conceptually not unit tests, and they're not really integration tests either. So you should also have unit tests, you should also have integration tests, you should have all these other types of tests. But that's not the type of test we're talking about here. We're talking about tests for a very specific purpose, and that is to explore the domain model. So that's how we're using tests in this context. Another important point is when you're writing these tests, we're actually coding these scenarios, you want to use very concrete scenarios. You don't want to say person A, you want to actually use a real person's name. It could be a made-up person for privacy reasons, but don't use abstract concepts. As software developers, we're really great at abstraction, and abstraction has its uses, but this is not a place where we really want to use abstraction. We want to be very, very specific in these scenarios. So the interesting thing about this election scenario is that what I've done here, I've actually added comments. These code comments are word for word from the scenario you saw earlier. So I could actually read this test back to a domain expert, and using the ubiquitous language, I could explain to them what's happening here. So I think you'll agree as you look through this code that the code expresses the concepts in the scenario. So for example, the first part of the scenario says, again, this is word for word from the scenario we saw earlier. The town meeting day 2011 election event is underway. So we're instantiating a new election event with an identity of town meeting day 2011. So you can see that we have a very close symmetry between our scenario and the actual code, because we want to actually be able to explain this to a domain expert. Now, the domain expert may not actually be able to read the code, but with you sitting there with them, you can translate it for them into language that they understand. Ward 3 in the Municipality of Burlington. Okay, how do we implement that? Ward 3 equals new Ward 3. Burlington equals new municipality. Ward 3, set parent district to Burlington. Done. We now have a Ward 3 in the Municipality of Burlington. Is holding an election for city councilor. Okay, we create a city councilor election. We set the election event to the town meeting day 2011 election event. We set the district to Ward 3. Is there a question? Or? Okay. So I'll give you a minute before I go to the next slide to take a look at this. But again, the point here is that the goal here is we're trying to create a model that can express domain concepts. So we're trying to make domain concepts explicit in the design of our code, and in our tests here, we're trying to express those concepts. Okay, the next part of the scenario says, this election has 3 candidates. Okay, here's our 3 candidates. We instantiate our 3 candidates, and we assign the election to them. So we associate the candidate with the election. Next part of the scenario is, it is 8:30 p.m. and Ward 3 has indicated the following results. So here I've deviated a little bit from the scenario, in that in the scenario, it lists both the number of votes and the percentage of votes for each candidate. But that would be silly. We don't want to set the votes and percentage. We should just set the votes and calculate the percentage. So what we've done here, as you can see, for each candidate, I've set the number of votes that they received. And then I have an assertion on the get fraction of votes method, just to make sure that it's calculating them correctly. So that Vince Brennan has 60.2%, Lynn Mizik has 29.1%, and Ron Ruloff has 10.7% of the votes. This election has a winning threshold of 40%. Okay, instantiate a new winning threshold value object, setting its minimum percentage to 40%, or 0.40, and associating it with the city councilor election. So candidate Vince Brennan, progressive, appears to be the winner. So winners, we do call the determine winners method on the winning policy. We then assert that Vince Brennan is in that collection, is in that array, and that Lynn Mizik and Ron Ruloff are not. So again, you can see we've actually just literally taken that scenario and expressed that scenario in code. Does anybody see any implicit concepts that should probably be made explicit? Has anything jumped out at folks as implicit concepts here? So one thing that's implicit is this idea of what party the candidate belongs to. We've actually made the party part of the identity of the candidate. Perhaps that should be something that's separated out, and that's an implicit concept that should be made explicit. So again, I don't know that, what I would need to do is I would need to go to a domain expert and have a conversation with a domain expert so that I could understand whether or not that was the case. But it appears here that might be the case. So we've got our scenario. Next thing we want to do is we want to challenge that model that we've come up with. So we're going to throw new scenarios at it. We're going to challenge our model, make sure it makes sense, and really rigorously keep throwing scenarios at it. So this particular scenario, here's a few questions we might want to ask our domain expert. What if 2 candidates reach the 40% winning threshold? Did anybody notice this flaw? Anybody happen to catch this? So if in our model that we have, 2 candidates could both get more than 40% of the vote, right? Because that's still less than 100%. They're not both winners. So we're actually missing something in our scenario, and that is that it's not just a winning threshold, it's winning threshold and plurality. So our model, we're missing something in our model there. We actually need to be able to combine multiple winning policies together. We need to be able to combine winning threshold and plurality together, so that if 2 candidates get 40%, we then pick the candidate with the highest number of votes. What if a candidate participates in 2 elections? So perhaps we're missing another concept here, because it's certainly possible that a candidate could participate in multiple elections, or, well, I assume it is. Again, I shouldn't make those assumptions. I should go ask a domain expert. What about a municipality without wards? This scenario was one with wards. Should we run it through a scenario without wards? See if there's any differences. What about an election that's won by plurality? We should probably check out one of those scenarios. Referendums, are those different than elections? What comes up in those scenarios that's different? This was a town meeting day, so this was a local election scenario. What about general election? So again, the point of these questions is these are all conversation starters for you and the domain expert to to work together to come up with more scenarios to challenge your model. So a couple other useful tips here. So this is what Eric Evans calls supple design. So these are just a few tips. There's more of them in the book on some techniques to keep your design what he refers to as supple, easy to work with. So one neat concept here is this concept of closure of operations. So closure of operations says that you have a value object, and it has a method on that value object that returns an instance of the same type, of the same value object. And the method arguments are also of the same type. So a really simple example of this is 2 plus 3 equals 5. This is an example of closure of operations. 2 is a value object of type integer. Integer has an add method. Add method is accept an argument of type integer. So an add method returns an integer. So what we can say is that integers are closed under the operation of addition. So this is actually a mathematical concept of closure of operations. So here's an example of this in code. I've kind of iterated on the model a little bit. Now I have this concept of a valid item result versus just a candidate. I've kind of broken that out in this example. But the point here, though, is that we have this method called total on valid item result. The total method takes an array of valid item results, and it returns a valid item result. I'm cheating a little bit here because I'm using an array. I should probably use the composite design pattern here. But this should illustrate the concept where we can, so with this concept, we can actually wire together methods, and we can actually pass these value objects around and we can actually start doing complex operations on these value objects with this closure of operations concept. Some other techniques that can be useful, intention revealing interfaces. So basically, if you look at the interface for a method, is it clear what it does? Is its intention clear based on its interface? Side effect free functions. Does a method return a value and modify state? Hint, it shouldn't do both. It should only do one or the other. Most of the time, you don't want to modify state. You want to really isolate state changes to very explicit points in your code. State changes are a big source of bugs in code. So side effect free functions are a way you can try to avoid those bugs. Of course, you have to change state at some point, but I'm not saying you don't ever change state, kind of a useless system if you don't. But the idea is to really isolate those state changes to where they need to happen. Are there other interactions? Does your method call out to other objects or other methods that might be modifying state? Assertions. Has anybody used the assert function in PHP? Have you ever used that? A couple people. Awesome. I was expecting no hands, so a few people have. So the assert method, or assert function, in PHP is basically it's something that it's a function you can call that should you pass it a Boolean expression, and it's something that should always be true. So these aren't exceptions. Exceptions are things that should most of the time be true. Should be true 80% of the time or 90% of the time. Assertions are things that should be true all of the time. It should never be false. If it's false, something is seriously wrong. So assertions can be useful for checking two things. Preconditions to a method. As you enter a method, what state must be true as you enter that method? Postconditions. As you exit a method, what state must be true? And you can call the assert function to make these assertions for the preconditions and postconditions. By default, the assert function in PHP is on and will trigger a warning. You can configure it to, if you'd like, you can actually turn it off if you'd like. Say in production, you don't want assertions running. You could also have it trigger an error instead of a warning, which is probably better. And you could even have it do a callback function if you'd like. So if you want to do something more advanced, you could do a callback on assert. So let's back up and look at these examples. So first, intention revealing interfaces. So if you take a look at this particular interface, the get fraction of votes method on the valid item result, is it clear what it does? Arguably. I'd say it's fairly clear what its intention is. Maybe it could be clearer, but. side effect free. So here's an example of a side effect free method. The determine winners method in our winning threshold value object. This doesn't change any state. It calculates who the winners are, returns those winners. No state is changed in the process. Preconditions and postconditions. So in our determine winners method, let's add some assertions. At the very beginning, we have two assertions. Minimum percentage must be greater than or equal to 0 or less than or equal to 1. Minimum percentage has to be 0% or to 100%, right? If it's outside that range, something's seriously wrong. So we can assert those two preconditions. At the very end, we can assert the postconditions, that the number of winners, the count of the number of winners, is less than or equal to the number of candidates in that election. You can't have more winners than you have candidates, right? That's invalid state. So we're asserting that postcondition here. Yes? So the Yep, so the question was, would you make an exception to the rule about not changing state for things like caching? And what I would say there is there's a difference between logical state and physical state. So what we're talking about here is logical state. So logically, this shouldn't change any state. Now, if you really know what you're doing and you're really careful about it and you want to cache stuff and you can guarantee that logically it's never changing state, even though physically there's a cache that's happening to improve performance, that's perfectly fine. But there's that's a physical thing, not a logical state change. So advanced topic. So a couple things. These are a little bit outside the scope of domain-driven design, but still related topics. Just going to talk about really briefly. Event sourcing. So event sourcing is pretty cool. So the idea with event sourcing is that you model your domain around domain events. So domain events are important things that happen within your domain that result in state changes. So domain events can trigger other domain events. For example, if you're modeling a baseball game, 3 strikes could trigger an out. So there's an example of events triggering other events. Domain events are like value objects. They should be treated as immutable as well. You can create new domain events to correct state if you need to, but a particular domain event, once it's instantiated, should not be changed. So what you do is you store these domain events in an event log, and you can actually compute the state of your system by reading the event log. So we're actually not ever storing the actual current state of the system. We're calculating the current state of the system. Now, that could potentially be performance issues. It actually can be pretty fast, but if you'd like, you could cache that if you need to. Again, this gets at the difference between logical and physical state. So logically, we're always computing the event log. We're computing the current state from the event log, but we might want to cache things for performance reasons. Next thing here, has anyone ever you might have in your past needed to build an audit log into your system? If you use event sourcing, you have a built-in audit log. So you know, you can tell exactly what's changed when by just reading the event log. So it's a really nice added benefit you get for free. Another related concept is command query responsibility segregation, or CQRS. So when we're modeling entities, we tend to think in terms of symmetry. If you're going to have a get foo method and a set foo method on an entity, in other words, reading data and writing data, you're going to have some symmetry there, that getters and setters. You're going to have a getter for every setter. But why? Why do we need to do that? Why does the model for reading data need to be the same as the model for writing data? So with CQRS, we actually separate our read model from our write model. We have two different models for reading data and writing data. So we have commands responsible for writing data, and we have queries responsible for reading data. Now, both are conceptually working on the same aggregate. From a conceptual point of view, we're dealing with the same aggregates here, but we're we're separating out how we model this. So CQRS and event sourcing actually go really well together because you can use commands, you can use events and commands to change state. Those go into an event log, and then you can have another system that then reads that data out for your read model. Great, so that's all I've got for today. I've got a few minutes for questions, but just real quick, I've got a couple of books if you're interested in. These aren't directly related to this topic, but writing and querying MapReduce views in CouchDB and scaling CouchDB. I've got some discount codes for those if you're interested. If you have any questions after this, we've got a few minutes now for questions, but if you have questions later, feel free to hit me up on Twitter, or but you can also find me at my blog at bradley-holt.com. Please, if you don't mind, go to join.in/7025 and give feedback on the talk. Really appreciate that. If you could let me know what you thought of it. It just helps to make improvements to the talk in the future. Great, so if you don't mind, if you have a question, could you please come up to one of the mics on either end of the room? Anybody with a question? We've got probably about 5 minutes, I think, for questions. Anyone? Yes?
My question is about, I forget who you referred to it, but the domain glossary.
Mm-hmm. Yep. So ubiquitous language, yep.
Ubiquitous language.
Yep.
Many times we need to create more detail and granularity for purpose of modeling than the domain experts are normally used to thinking about, because things have to be decomposed more than they really talk about. So I've faced challenges where I have to create kind of longer, specifically like entity names that they wouldn't normally interact with, and I find that I guess I've tended to train them to use those terms in a certain way. It's kind of like a two-way street. Is that forcing the issue a little too much?
No, I don't think so. I mean, I think if those terms are needed in order to solve the problems, the point is that you're trying to solve domain problems that they're experts for. So if you need those tools as part of to solve those problems and they're not familiar with them yet, perhaps that's an opportunity to further develop the domain. Maybe there are things lacking in the domain that you can work together with collaboratively to develop. So it sounds like you're doing the right thing there with going back to them and trying to define and use those terms, because now you can actually have more expressive conversations with them because you have more detailed terminology to use. So.
Right, and then the challenge I find is then to what level do you surface those new concepts to the UI? You know, sometimes it's only important for the people that really understand it at a low level.
Yep.
And then how to simplify that from a labeling point of view.
Yep, so that's a really good question. So yeah, so most of what I'm talking about here is all domain modeling layer, and you really want to focus on like not actually how it's going to end up in the UI, but eventually in a real application, you're going to have a user interface. So, I mean, if at all possible, you really want that ubiquitous language to bubble up and be used in the UI, used everywhere. It can be across the system, but I mean, that may not always be practical. But I guess in that situation, you could consider it a form of a translation. So perhaps you use some sort of translation tool to say, okay, for these users, they're not going to understand this technical jargon we're using, so we're going to translate that word to something more meaningful to them, or something easier for them to work with.
In some cases, you may have a template and then an actual instance which have this exact same model that have to be copied, and you need to strip away some of the difference between them from the user's point of view because they don't want to think of it.
Yep. Yeah, no, that definitely, and that definitely comes up in user interfaces where it's as much as you want to stick to that ubiquitous language, sometimes things need to be simplified a little bit at that level. So, yeah. Sure. Thank you. Any other questions? Yeah? Okay. Yes.
Somewhat following up from what the previous gentleman was talking about, looking at your example, one thing that kind of noted was the sort of the scoring of the candidates, the sort of the fractional value.
Yep.
With the precision, it looked like you had like 3 decimal.
Yep.
Precision. Would that be part of the ubiquitous language, or is that getting too sort of nitty-gritty?
It probably should be. Yeah, that definitely probably should be. The only reason I did that was to make the PHP unit test work, because without that precision, it would have you would need to make the unit test add more methods on the assertion, add more parameters to the assertion. So that's why I did that. But yeah, that's something that should be probably explicitly worked on, and what level of precision matters here. And perhaps it's, yeah, exactly. And maybe even the concept of percentage should be a value object. I don't know. I mean, maybe that's going too far. I don't want to make everything a value object because if it doesn't need to be, but perhaps it should be something that's made explicit with explicit concept of precision to it. So.
Okay, thank you.
Sure. Did that question looks like? Yep.
First of all, great talk. Really appreciate it. Been reading your book. Fantastic stuff. Can you talk about, just real quick, I have an application. I've been intuitively doing a lot of the stuff you talk about, but you know, the application's 2 years in the running and we've made some mistakes. We want to go back and correct it. Or maybe I have an application that I haven't used any of the DDD style for at all. How do I take an existent, I can see how this could work with a new application that I'm building from scratch. What about applications that already exist? How do we apply these principles?
Yep.
In that context?
Yeah, great question. So I'd point you to the strategic design section in Eric Evans' book. That's where he talks about things like the context map, for example. So where you actually take what's out, sit down, spend some time to actually map out what exists, what the context map is, what areas need improvement, and I would say really in that situation, distilling the core is really important because you want to, well, as much as you want to clean up the entire code base and fix everything, it really matters most in the core domain. So that's why the context map matters, because you really want to be able to isolate that, define which one's the core domain, and focus your cleanup efforts there. Or else it's just you're gonna be, wasting your time all over the place and fixing things that aren't as critical. So I would say there it's identify the core domain, focus there, and focus on that for cleaning that up and refactoring that area of the application. Sure. Is there anything else? Or? Yep.
So for the domain-driven design, we're really trying to move towards, in the group that I work with, on the testing side, or behavior-driven design using BHAT and tools like that.
Yep.
Can you maybe talk very quickly about how they kind of relate is more of like do you see BDD as being a feature, as being a particular domain, or how do you see that playing out?
Yeah, I mean, I think behavior-driven design is interesting. I think what I've seen with the culture around behavior-driven design is the focus tends to be on letting domain experts actually write the tests, which I have mixed feelings about. I think it's important to work collaboratively with them. So usually the problem is that software developers are going and modeling it, and we're just doing it in isolation. And I think behavior-driven development potentially risks going the other direction, where you just have the domain expert writing the test without a software developer. So I would say I think it definitely could be useful, but the key point would be to make sure you're still working collaboratively between both the software developer and the domain expert. You're not just having one or the other doing that work.
Okay, thanks.
Sure. Yeah.
My question sort of relates to how domain-driven design can work with the experts on a sort of two-way street process. I'm just wondering how your experience has been with trying to help or get domain experts to sort of distill the rule set so that things aren't always complex. You know, you might have some sort of strange rule set that's like, we tax everybody at 5%, but if the third character in their name is, then it's 6%. You have these really weird rules.
Yep. Yeah.
I'm wondering if you could talk a little bit about that kind of.
Yeah, I mean, so that's a tough one because it's a lot of those issues are actually probably areas where there is complexity in the domain, and perhaps they seem like they're arcane rules or things that are added by the domain expert, and why does it matter? But perhaps there's something that if further conversations and further refinement might get at some concepts hidden in those weird corners of things. So I would say that in software design there are no edge cases in software design. Software development, absolutely, but in the design phase, edge cases are probably a sign of some other thing hasn't really been explored well enough. It needs to be explored further. Or it could just be them stuck in their ways about how an existing system works. Sometimes you'll have somebody who used to work on a previous system and they're thinking in terms of how that system worked. So it could be another thing too. Maybe it actually isn't an important concept. But that's really the kind of the subtleties to this is really trying to synthesize that domain knowledge and trying to identify what's important and what isn't. So there's no simple answer, but hopefully that helps give you some tactics to work with. So, yeah. So I think we're probably out of time here. So if you have any other questions, feel free to hit me up after. I'd be happy to talk more about this with you. But thank you, everybody.